Hello, my name is Amber Butler, and I'm going to be talking to you about makerspace projects. Makerspace, by definition, is student-centered learning. A makerspace could be a classroom, a cart, a corner of a room with just items that a student may be able to build something with. A lot of times teachers will use like recyclable items or paper. Sometimes there's like technology involved. A makerspace has to do with STEM or STEAM, which stands for science, technology, engineering, arts, and math. These type of projects promote problem-solving skills with students, critical thinking, innovation, and so many other real-world application type of skills, all while being creative. A makerspace makerspace projects encourage students to use everyday objects that might be laying around in the classroom, at home, at the park. I mean, the options are endless, and that's kind of the whole idea. Students will find these items and turn them into something awesome. If you give them a pile of sticks, some glue, and some cups and tell them to build a bridge, kids will go have at it, and they will go all in to see how big they can build their bridge, how strong their bridge can be. So it's just really truly where the creativity comes into play. Students are exploring subjects that might be harder to understand and comprehend through a traditional lecture style lesson. Just because they're using a hands-on approach, they're learning through creativity, brainstorming, creating, sharing, collaborating, all while learning this content. A lot of the times people ask, like, how do you assess these type of assignments as opposed to a worksheet or a test? Students are self-reflecting and self-assessing throughout the process. So if, back to our stick example, if students are building a bridge, they're going to self-reflect after the first trial. How did my bridge do? Did it hold as much weight as I wanted it to, or does it need to be stronger? So they're self-reflecting, self-assessing, and then they kind of go and fix it then. As a teacher, I am watching my students to see how they are learning and growing from the makerspace objects or products. Are they building these skills that I'm looking for? The problem solving, critical thinking, are they innovating? Are they using these real world skills within their development of the project? I'm going to talk to you a little bit about my makerspace, which is all about ramps. I'm going to share my screen. Okay. Let's not. Okay, so we have. So this is my template, building ramps and how far will it go. So we're working on distance. The building aspect is math and science together, obviously. Students will be brainstorming and using blueprints. These are some materials they can use. They can use a cereal box, Legos, a car. They can use their feet to measure if they don't have a ruler. These are just some QR codes that kind of talk about ramps. Other ways they can use ramps to explore. Maybe you could try, like the student might want to see, okay, I've tried to see how far I can roll a ball off my ramp. They might want to look into, does a ball roll better on a flat surface or a bumpy surface? So that's what this kind of talks about. Is a read aloud and online whiteboard. This really brings in the technology aspect of STEAM, giving students the opportunity to use technology as opposed to paper and pencil. I like to try to encourage both, just so that way students can see what they like best. So this is their blueprint. The student's job is to write, draw, or show their plan. So before they do anything, they need to come up with a plan. I say here, like, you can make changes. So this is to encourage that it does not have to work the first time, and it's okay if it doesn't work the first time. Testing, this is where students will record their data. So this is where the science aspect comes into play. So they're going to record their data. The first test, how far did your car go? How many footsteps or inches? We have both, that's math. Additional comments, so what did they notice? The first one is a little bit kind of more of just observations, whereas tests 2 and 3, they can answer and compare with their previous test. Did it go further than the last try? What did you do differently? And then at the end, they have a reflection. What was the furthest your car went? How many footsteps and inches? And then we kind of talk about steep, how tall or steep was their ramp, and which one worked better. So then these are our standards that kind of go into my lesson. I want to share, these are some student work samples. So again, the opportunities or options for a makerspace are endless. So this student used a cookie sheet and cookbooks, and they used a ball, they wrote a ball down. The student used wooden blocks and cars. The student used cardboard box and just a flat piece of cardboard with cars. They kind of added some lanes on their road. This student used a bouncy ball and Legos. I don't know if you can see that back here, and a cardboard box. So again, the options are almost endless. This student might want to use their steps outside to their porch. They might put their piece of cardboard on the bottom step and see how it goes, and maybe they'll go to the second step and so on. I will show you, I have a video here. This is from the first student work sample, just kind of like how they tested it. So then it's kind of short, but at the end they could use their feet and from heel to toe measure 1 foot, 2 feet, 3 feet, and then they could get their ruler or their tape measure and see how many inches it is total. So that is my makerspace, and kind of what a makerspace is. It is student-centered learning. It is all about creativity and integrating science, math, arts, engineering, technology. Again, I'm focused on science and math for this one, but again, the options and opportunities are endless. Thank you so much for listening, and have a great time with Makerspace.